Hello everyone, I hope you all are fine and you are getting my lectures. Dear students, in my last lecture I taught you about nucleus and nuclear forces. We have studied about some very important properties of nuclear forces, like nuclear forces are saturated forces, nuclear forces are independent of charge, and nuclear forces are the strongest forces in nature. Students, now today we will cover a very important topic, that is mass defect and binding energy. Students, so let us start our first one topic, that is mass defect. As you can see, mass defect, its name is only indicating that it is some kind of disorder. Okay, so students, mass defect means difference between sum of masses of nucleons. I told you that nucleons means proton plus neutron, and rest mass of nucleus. Students, if you will take nucleus as a whole, then its mass is different. But if you will measure the mass of proton and neutron, then it is different. That means this difference, for example, if I will tell you that mass of nucleus is 48 gram, but the mass of proton and neutron is 50 gram. So what is the difference between both? Difference is of 2 grams. So that 2 gram difference is known as mass defect. Actually, what should happen, that as you know, in nucleus there is proton and neutron. So total mass of nucleus should be equal to total mass of protons plus total mass of neutrons. But it was observed that this is not so. Means there is some difference between mass of nucleons and mass of nucleus, and that difference is called as mass defect. I hope students it is clear. And this mass defect is denoted by the letter delta M. Capital delta, just like triangle, M. Delta M. Okay, so we will find expression for it, which is very simple. A, we have taken mass number. Z, we have taken atomic number. And students, you know atomic number is equal to number of protons. A minus Z is number of neutrons. How to calculate neutrons? A minus Z. So what is delta M? Now mass of proton plus mass of neutron minus mass of nucleus. How we are writing mass of proton? Students, small mp is the mass of one proton. There are total Z protons. So total mass of proton is Zmp. For example, if mass of 1 proton is mp, then mass of 10 protons will be 10 mp. Similarly, mass of Z protons will be Zmp. Mass of 1 neutron is small mn. Mass of A minus Z neutrons will be A minus Z mn. And whenever I am writing capital N, it is the mass of nucleus. Students, here it is small n, means mass of neutron. Here it is capital N, mass of nucleus. I have written downwards total mass of proton, total mass of neutron and nucleus. Proton and neutron, this is collectively called as nucleons. So it is mass of nucleons minus rest mass. So this minus sign means difference, means defect. Okay. So now simple mathematical interpretation we have done. Zmp plus E minus Zmn plus Zme minus Mn minus Zme. Now students, just observe what I have done. Pause your video and see what I have done. As we are doing many times, I have added one value and I have subtracted the same value. I have added Zme, I have subtracted Zme. Zme means mass of total electrons, because electrons are also equal to atomic number. I hope I am clear. Okay, so Zme I have added here, Zme I have subtracted, so no change. So students, now Zmp, Zme, I have taken these two terms together, this term and this term, this term. So these both terms I have added, Zmp plus Me plus A minus Zmn isolated as it is, and these two terms also I have joined, minus sign I have taken outside, M capital N plus Zme. Okay. Now you just see one mass of one proton, mass of one electron. किसमें एक इलेक्ट्रॉन एक प्रोटॉन होता है? Hydrogen. So it is H11, hydrogen. A minus Z is same. Here nucleus and electron. In nucleus there is proton, neutron, electron. So proton, neutron, electron is a mixture of what? It is atom. Okay. And how we denote atom? XAZ. Is it or not? Okay, so students, this is the final expression for mass defect. Delta M is equal to ZH11, means the atomic number is 1 and mass number is also 1. A minus ZMN MXAZ. So this is the expression for mass defect. And now our next important topic is binding energy. Students, binding energy means the energy which we require to separate nucleons. As you know, nuclear forces are there between nucleons, proton, proton, neutron, neutron, proton, neutron. So those forces we need to overcome, and to overcome those forces we need some energy, and that energy is called as binding energy. So it is defined as the work required to separate nucleons to a finite distance. Okay, and binding energy per nucleon means to extract one nucleon from nucleus. Nucleus में से आप एक nucleon निकालना चाहते हैं. How much energy you will apply? That is binding energy per nucleon. Okay, it is just like that you have a basket of apples and you want to take one apple from there. So how much force will be applied? How much energy you will apply? Okay, so binding energy per nucleon, you can write Be upon A, where A is mass number. Okay, now students, our next topic is very important, that is binding energy curve. Binding energy curve is nothing but, definition is not written here, please write definition. Okay, that binding energy curve is a graph between binding energy per nucleon and mass number. Once again I am telling you need to write in your notes notebook. Binding energy curve is the graph between binding energy per nucleon and mass number. Okay, so this is binding energy curve. So you can see on the y-axis I have taken binding energy per nucleon. On the x-axis we have taken mass number. Then graph you have to draw just like this. Okay, this graph will possess 3 curves and then it will be flat and it will end at uranium 235. Everything you have to write in the similar way. So what is the conclusion? Let us study. First point, binding energy for light nuclei is very small. Light nuclei means like your hydrogen, means halka, जिसका weight बहुत कम हो, light. Okay, so binding energy for light nuclei is very small. That means they are very unstable. Okay. Second, binding energy per nucleon increases rapidly for nuclei up to mass number 20, and then the curve possesses 3 peaks. Very important, 3 peaks. At what point? Helium, carbon, oxygen. And these peaks indicates that the elements are more stable than the neighboring element. Very important second point. This curve is possessing how many peaks? 3 peaks. And what does peak indicates? Peaks indicates that these elements are more stable than the neighboring element. Okay, this question may be asked in MCQs also. That what does the peaks indicates in binding energy curve. So binding energy curve में peaks क्या indicate करती हैं? That the elements are more stable than neighboring one. Okay, next third point is, after mass number 20, the binding energy increases and the curve becomes flat between 40 to 120. So between 40 to 120 the graph is flat. And then in question number 4 you can see that the binding energy per nucleon decreases and it drops. It drops to 7.6 electron volt for uranium. Question may be asked, what is the Binding energy per nucleon for uranium, it is 7.6 electron volt and it is unstable. So from this whole scenario, it is clear that iron and nickel, for them the binding energy is more. That means they are more stable. Okay students, so this is all about your mass defect and binding energy. Take a screenshot and please do complete your notes. Don't forget to comment for your attendance. Okay, so students, this is enough for today. Thank you. Have a good day.